Hello everyone. Today I would like to talk about a normal distribution and when something is statistically significant. So what do we mean with these words or notions? Now, let's say we have a measurement where we want to know the average height of the American male, okay, or American female. So you come up with like 50 men, you measure them, and their height will be somewhere around maybe 6 foot 0 inches, right? And then another person you measure, he is 5'9", 6'1", 6'2", 6'1", and so on and so forth. So what you do is you record all the sizes, and then you can draw them on a graph. Where the size is on the x-axis. Let's say maybe he is 6 foot, yes, 6'1", 6'2", and so on. And here is 5'11", 5'10", and so on. Okay, so in this case, 6'0" is the average, right? We find that 6'0" is the average, and then we'll find if we have the frequency here of men who are that size, that most of them are that size, 6 foot, right? That's our average. And then we have a few less that are 6'1", maybe they're here. Same for 5'11", and so on, right? And what we'll see usually is that we have something like a so-called bell curve here. If we take now not just 50 measurements, but 1,000 or 2,000, we'll see that this curve will basically become continuous, and we'll have something like this. Okay? So this is a so-called bell curve. And there's a mathematical way to describe the bell curve, but the most important thing is that the vertical axis is the frequency of appearances, and the horizontal axis is the size or weight or whatever parameter you measure. Okay? So you get this bell curve. And now you can ask, well, if that is our distribution, and we have a guy that is 7'1", is that guy really significantly higher, significantly larger than the average male population? A 7-foot-something guy will be somewhere, let's say somewhere here, a very rare event, right? Let's say maybe he's here. But is that really an outlier here, so to say, or will we find some other men that are 7 feet high if we just look at enough men already in this population, right? That's the question. Basically, is our 7-foot guy just a very rare occurrence of our general sample, or is he really different? And so what we can do is we know that this here is all the sums here, right? If we take all this together, we get the total population number, like all 1,000 men or all 10,000 men that we measured. And then we say if now a height from that sample is within like very small area, very low frequency on either side, and this frequency is so low that we cannot possibly have it taken by chance from the main sample, then we say it's significantly different from the main sample. In other words, if the 7-foot man, if the chances of grabbing a 7-foot man out of our total population is about 5% or less, right? If only 1 out of 20 guys we look at our normal population is 7 foot tall, or even 1 out of 100 guys in our total population is 7 feet, then we say, well, this is a result, this is probably not by chance, this is such a low likelihood, this guy is probably not coming from that population. That guy is probably not American, that guy is probably Scandinavian or an ancient giant, okay? So that's basically, in a nutshell, what significance means and how population are distributed. Most population, like the weight, height, the speed of athletes, and maybe even the wins of a football team and all that, everything that you can measure is usually normally distributed. Not in all cases, but in many cases with very simple parameters like weight, height, and so on. They are usually following such a bell-shaped, bell curve distribution. And we can then basically, there are tables, and I can get more into detail in a later version, but there are basically tables that can show you whether the value you're looking at, in this case a 7 foot tall guy, how likely it would be to have this guy be part of the normal population, right? And if it's only 1 out of 100 times likely to be from the normal population, then we can say, well, it's like that guy is probably not from our normal population, or it's very unlikely that we grab a size like 7 foot out of our normal population by chance. And that's all that's behind significance, right? A significant change is something that is very unlikely having resulted from a chance encounter in our original population. A significantly different number means a number that is probably that is very unlikely to have come from the normal population. And that's in statistics significantly different. And that's what it means. That's what significance means. All right. Thank you for listening, and catch you on the next one. Bye.